Hello and welcome everyone. I hope you're all doing well. My name is Jordan Stacey. I'm a certified Ignition developer at Australian Control Engineering, and today I'll be leading you through a demonstration SCADA project developed here at ACE, specifically using Inductive Automation's Ignition SCADA platform, with my goal being to highlight both the platform's modern capabilities and ACE's integration expertise that we can provide to you. Before we get started, I'd like to give an outline to the ordering we'll follow for this demonstration. First, I'll start by giving a brief overview to Ignition and the project that you'll see in front of you now. I'll then move into the project's alarming capabilities, including context-sensitive displays, current and historical alarm logs, along with real-time and historical trending, which I'll follow by demonstrating more advanced features of the project, which allow for seamless scalability for additional data and assets, utilizing the power of Ignition's scripting and templating functionality. Excellent. Let's start out with an overview. As you may already know, our expertise here at ACE lies within utilities, with a specific focus on integrating smart controls and SCADA within power and renewables industry projects, including wind, battery energy storage systems, solar, gas, and more, where we are currently delivering solutions to a range of clients. With this in mind, we feel it's appropriate to demonstrate our Ignition capabilities with energy at the forefront. As such, our project mimics a telemetry-fed central SCADA system, retrieving data from a multitude of independent energy generation sites around Australia, which you'll see on our main overview page. This data is being communicated via an external Kepware server connected to an Ignition Edge installation on the network, where Edge packages this tag data using MQTT Spark-Plug-B payloads for communication to our central Ignition gateway, simulating site to central operations data transfer. At the central installation, payloads are translated back to OPC tags to populate HMIs in real time and store in historical databases located elsewhere on the network for trending and analysis. You'll note the SCADA HMI on your screen is running in a web browser separate to any Ignition installed device, allowing access for operator monitoring regardless of location alongside device type, with fully mobile scalable design leveraging development with Ignition's perspective module. Real-time adaptive, as you can see me demonstrating now. Focus now on our wind sites along the top row of our templated site displays. You'll see critical overview statistics be calculated using Ignition's expression and scripting languages polled in real time utilizing existing MQTT data collected from site turbine assets. Where you'll see on Melbourne Wind Site 3, I've just triggered east side turbines 1 through 3 to stop operation, and the calculated summary statistics have been updated in real time. You'll see later dynamic fault statistics in our alarming discussion. Obviously, data beyond summary statistics is desired within a central SCADA system. So let's explore how our demo solution achieves this. As you would expect, hovering over individual sites' overview cards indicates we can drill down. Clicking into the site navigates us through our map to the site's geolocation, where we can see the site via GeoJSON data, and further drill down, clicking onto markers to view the individual assets. It's easy to see within our templated assets overview the status of the upper left 3 turbines we stopped, with text, animation, and context-sensitive highlighting. As with all our templates, this assets overview is fully mobile adaptable, allowing remote operators to accurately view the data. Oh, that's an issue. It looks like turbine 8 has stopped unexpectedly. Let's drill down the hierarchy further to investigate. From this view, we can see specific statistics related to the individual asset. As before, the overview is fully resizable. Based on that fault code, everything appears okay. Let's attempt to start back up the turbine. Oh no, the toggle button looks to be disabled. This is due to the role-based access we have implemented as part of this project. Let's see who I'm logged in as. It appears I'm logged in as an administrator. Let's log out and then go back in as an operator account. Here we are on our operator account, auth participant 1. Implemented as part of this project is multi-factor authentication through Microsoft Entra ID using OpenID Connect 2.0 protocol. Let's verify and log in as the operator. Using Microsoft Authenticator, let's authenticate. Our authentication has gone through, and you'll now see we're able to press the toggle button without issue. The value's changed and looks good. Let's see that change back in our asset overview. To do this, let's use our templated back button as we'll see below. Yep, everything looks good from here. The context-sensitive orange highlighting has been removed and the animation is playing. It should be noted that as we're in the browser and have implemented paging properly, we were also able to use the back arrow in order to navigate back to the site's asset overview. Let's try this now. As expected, we've navigated back to the turbine's detailed overview, conforming with a back navigation. Now we want to travel back to our overview screen for the next part of our data. Let's use our collapsible side navigation bar. We can resize this as we wish for both mobile and larger displays. Let's collapse it to the mobile size and click back using the overview button. We can verify this was successful through our menu's grey context highlighting. In addition to this, we can navigate to our map for an overview without entering an individual site. Let's go back to our overview now. Finally, let's quickly try to navigate to the asset details of one of our WA wind sites. Let's try WA wind site 3. Instead of clicking through all the menus, let's use the implemented page path system in our browser's navigation bar to allow for rapid operations viewing. Here we are with no problems in a rapid navigation. Let's go back to our overview. So that brings us to the end of our overview. We'll now move on to both trending and alarming present within the demo project. Let's start out with our trending functionality. As you'll see, hovering over individual fields within the WinSite's overview card indicates the ability to click and expand the data. Clicking into the field then opens a templated pop-up for the historical data power chart for the value, which pulls in historical site MQTT data from a MySQL database on the network, alongside with polling for updates in real time as new data is fed in. A multitude of settings are available for dynamic operator tuning of the chart, located at the top edge. From here, we can see that the template is defaulted to show the last 4 minutes of data. However, can be arbitrarily altered as needed. Let's say double the range to 8 minutes, as I'll demonstrate. In addition to real-time intervals, historic intervals for data can be defined. Let's select for the past hour. And windows within this interval can be selected. Individual values for data points can be queried, alongside annotations made, as you'll see. Additional summary statistics can be viewed within the footer, for example, maximum, minimum, and within the range. These summary statistics can be altered, let's say to remove this X trace. Alongside a multitude of other options. Data on the chart can also be exported from the HMI view for analysis as required. All time-relevant data has pop-ups for historical trending. including detailed turbine data. Let's navigate back to WA Winsight's 3 assets once again and click on the gauges. In addition, a customizable trending chart to select desired values across all sites is easily available. Let's navigate to this page using our side navigation bar. From this view, we can click on the tag icon and pull desired data from all historic databases. Let's use this view to compare the wind speeds from Melbourne Wind Site 2 to Melbourne Wind Site 3. Looks to be tracking well. Let's move on to alarm functionality. A multitude of context-sensitive displays have been developed for this demo. Let's trigger a set of faults on Melbourne Wind Site 1 to see them in action. As you see, a real-time display warning has been highlighted around the overview alarm icon, and 3 faulted turbines have been indicated on the summary statistic. Let's click into the alarm icon to see what's happened. The status table is letting us know that 3 faults of low, high, and critical severity have been triggered on East turbines 1, 2, and 6, with fault codes as listed. Let's acknowledge these, as we know these are false alarms. And navigate back to the overview, where we can see that as the 3 turbines still remain faulted, the context-sensitive display remains. Let's clear these alarms and note that the context-sensitive display disappears. As expected, the number of faults are down to 0 and the context-sensitive display is removed. In addition to a status table for alarms on each site, the overview contains an icon linking to historical alarm data. Let's see if our acknowledged alarms are displayed after they are polled from our database. We can see that low, high, and critical alarms have been acknowledged alongside cleared. The implemented alarm table also allows for alteration to filtering. So let's see if we can remove the low severity alarm from the table. Success. And let's filter for just critical alarms that have been cleared and acknowledged. Now only those that have been acknowledged. No problems there. Looks like an alarm just went off on one of our wind sites out of view from that warning light. Let's take a look. Looks like it was WA Wind Site 3, but that right context-sensitive display is still running, indicating there's another site still at fault to the right. Sure enough, that was WA Wind Site 6, and our context-sensitive display has updated to the left to show us that WA Wind Site 3, which is now off-screen, is still faulted. This context-sensitive highlighting ensures operators will always be aware of faults regardless of the current wind site viewed. Instead of using the alarm status table, let's drill down into Wind Site 6 to find the issue. We can see a consistent faulted context display on this turbine. So let's investigate by drilling down. As we can see, a fault code of 1 exists on this turbine, retaining the context highlighting into the detailed display, indicating a low severity fault. Let's acknowledge this, but instead through navigating to the overview alarm status table for all sites, located through our side navigation bar. As can be seen, a similar context-sensitive display is shown, indicating that an alarm is present somewhere in our array of sites, allowing operators to view issues irrespective of their current view using the docked navigation. From the table, we can see both of our active alarms on sites 3 and 6. Let's acknowledge the one on site 6. No issues. That brings us to the end of our trending and alarm functionality showcase. Let's move on to our final demo of seamless scalability using scripting and templating. Given the wide array of sites we've already implemented as part of this demonstration, it makes sense that a realized version of this system would benefit from seamless scalability. With this in mind, we have developed scripts that allow for real-time updates to both wind sites and turbine assets to be sent to the central SCADA's HMI when a new site's MQTT data using the universal namespace is known to be received to the central Ignition Gateway's broker. This is achieved through a UNS-based comparison between the central gateway's site OPC tags and those currently read as part of the OPC translation of MQTT topics received from the sites to the central gateway's broker, where if new data is received based on the UNS, whether it be asset or entire site, and discovered during browsing, templated HMI displays will be formed using this data, alongside any current disparities corrected. As part of our demonstration, we will assume operators were notified that 2 new sites, a 5th Melbourne and 7th WA wind site, have been successfully commissioned and verified, and are ready to enter the Central Production Service SCADA. Including these sites on the HMI and beginning historical data logging is as simple as pressing the refresh button on the top navigation bar of the HMI, logged in as an operator user and having a designated IP confirming presence at a central location. Confirming my identity through the side navigation bar, I am logged in as an operator and given the simulation arrangement I am localized at central operations. I should be able to refresh and add these sites to production SCADA system via clicking the refresh button. Before we do this, let's verify that Melbourne Wind Site 5 and WA Wind Site 7 are not yet present. As we can see, these will be new sites. Let's try and add them. As you can see, a success animation on click has been displayed. Let's see if our new sites are now visible. That they are. Let's drill down into WA Wind Site 7 to verify the assets were added with no errors. All is well with no error context overlays. The addition was successful. Let's try that again, but this time from the map's perspective. As you can see, the new sites have since been removed. Let's press the refresh button once again. As you can see, the new sites have been added with their markers. Let's attempt to click into WA Wind Site 7 to once again verify the assets. Once again, a success. Now, let's attempt to finalise commissioning of specifically new turbine assets to Melbourne Wind Site 4. This can either be done using the overview card for the wind site with the same templated refresh icon, or through the site's asset overview. Let's try doing this through the assets overview so we can see the new icons populate in real time. With a click of our refresh icon, we can see 3 additional turbine assets appear corresponding to new West turbines 6 to 8. Let's get a replay of that from the perspective of the overview, using the summary statistics for Melbourne Wind Site 4. As you can see, before the addition of the 3 turbines, the total number of turbines was 23. Now, let's press the Overview's refresh button and see that number update. We can see the total number of turbines has now updated to 26, indicating 3 additional turbines were added. Let's drill down to Site 4's assets to see these additional turbines. Here we can see West turbines 6 to 8 were added in the same manner. That brings us to the end of our SCADA demonstration. I hope you've enjoyed watching as much as I have developing this example project and have a better understanding of what Ignition can look like for your energy projects. Have a great rest of your day.